Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam LTAM. For a fully discrete whole life insurance of $100,000 on a 35-year-old, you are given that in the policy year 1, the commission rate is 100% and per policy expense is 100. In policy years 2 through 10, the commission rate is 10% and per policy expense is 8. In the policy years 11 and later, the commission rate is 0% and per policy expense is 8. Per policy expenses are incurred at the beginning of each policy year. Mortality follows the standard ultimate life table, which you can find at smarturl.it/SULT, which stands for Standard Ultimate Life Table. Interest rate is 5%, which notably is the interest rate used in the Standard Ultimate Life Table. G is the gross premium, and that's also sometimes called contract premium. That's the actual premium charged, which includes provision for benefit, expenses, and profits. G is calculated such that the actuarial present value of gross premiums is 110% of the actuarial present value of benefits, commissions, and per policy expenses. C is the random variable for the present value at issue of commissions. Part A question is, E of C can be written in the form K times G. Calculate K. Part B, calculate the expected present value at issue of per policy expenses. Part C, show that G is 640 rounded to the nearest 10. You should calculate G to the nearest 1. D, calculate the variance of C. The company charges a premium of $57 per month for a policyholder who wishes to pay monthly. Commission rates during renewal policy years are as given above for annual premium policies. C star is the present value at issue of commissions for a policy paying premiums monthly. E, using a two-term Woolhouse formula, calculate the commission rate during the first policy year for a policy paying premium monthly so that the expected value of C star is equal to expected value of C. And here's the solution. The actuarial present value of the commission payments is E of C equals 0.1 G, 10% of G, A double dot 35 colon angle 10, plus 0.9 G, which is the addition you need for the commissions being 100% in the first year. It's 0.1 or 10% for the first 10 years, except for the first year when it's 100%. So that's what this is. And it's equal to 0.1 A double dot 35 colon angle 10 plus 0.9 times G. And from the standard ultimate life table, we find A double dot 35 colon angle 10 to be 8.0926. So this becomes 0.1 times 8.0926 plus 0.9 times G. So 1.70926 G. Therefore, the number K we're looking for is that 1.70926. For Part B, the expected present value at issue of per policy expenses is 8 times A double dot 35 plus 92 because of the additional expenses the first year being 95 plus, the total is 95 plus 8, so additional ones are 92 plus 8. So that 92 is added for the payment at time 0, first policy year. And A double dot 35 from standard ultimate life table is 18.9728, so this becomes 8 times 18.9728 plus 92, that's 243.78. Now, for Part C, G is calculated in such a way that the actual present value of gross premiums is 110% of the actual present value of benefits, commissions, and per policy expenses. Therefore, G times A double dot 35 is equal to 1.1 times 100,000 A 35 benefit plus 1.70926 G, which is the actual present value of the commission payments, we just calculated, plus 243.78, which is the expected present value at issue of per policy expenses, we just calculated. And this is an equation in which G is the unknown. We solve it for G and becomes G equals to 110,000 times 0.09653 plus 1.1 times 243.78 divided by 18.9728 minus 1.1 times 1.70926. And that's approximately 636.91. Now for Part D, in order to calculate the variance of C, consider this random variable, C, equals 0.1 G A double dot angle minimum of K35 plus 1 and 10 plus 0.9 G. So this is 0.1 G times 1 minus V to the power minimum of K35 plus 1 and 10 over D plus 0.9 G. And this implies that the variance of C is 0.1 G over D squared times 2A 35 colon angle 10 minus A 35 colon angle 10 squared. Of course, D is 0.05 over 1.05. It's approximately 0.047619. G is approximately 636.91. And 2A35 colon angle 10 is equal to 2A35 minus 10E35 times 1.05 to a negative 10. That's because of the doubling of force of interest that we need to take into account. So this is multiplied by 10E35 to get the double of force of interest effect, times 2A45 plus 10E35 times 1.05 to a negative 10. Because it's an endowment policy, it's not just life insurance, so we need to account for that endowment payment. And that's all of this is in the table, so we just plug in all these numbers in the table from the table. And this is this ends up being approximately equal to 0.37794. And therefore the variance of C is 0.1 times 636.91 over 0.047619 squared times 0.37794 minus 0.61464 squared. That's approximately 282.06. So one important lesson I want to note for you here is that you shouldn't calculate, almost always you shouldn't calculate a variance of an annuity-based random variable random variable corresponding to a life annuity. You should switch to life insurance in order to calculate such a variance, and that means that David Ricardo formula is always your friend for this type of calculations. For Part E, we have the expected value of C equal to 1.70926 G. So it's approximately 1.70926 times 636.91, and that's 1,088.64. Let C be the first year commission rate. Then the expected value of C star is 0.1 times 12 times 57 times A double dot 35 colon angle 10 upper 12 plus C minus 0.1 times 12 times 57 times A double dot 35 colon angle 1 upper 12 for the first year, of course. And then A double dot 35 colon angle 10 upper 12, and using the Woolhouse formula approximation, is equal to A double dot 35 colon angle 10 minus 11 over 24 times 1 minus 10E35. And both of the annuity and pure endowment factors are given in the table, so from the table we get this thing to be equal to 7.91417. And then A double dot 35 colon angle 1 upper 12 under Woolhouse is A double dot 35 colon angle 1 minus 11 over 24 times 1 minus 1E35. And from the table, this is approximately equal to 0.97800. so that this 1088.64, which we found to be approximately E of C, and that's equal to E of C star, which is approximately 541.33 plus C minus 0.1 times 668.95. Then we solve this for little c, the only unknown, and this is approximately equal to 1088.64 minus 541.33 over 668.95, the whole thing plus 0.1, sorry. That's approximately 0.9182. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.